Electrospinning is a process of fabricating nanofibers by charging polymer solutions with an extremely high voltage. This process is typically done on a stationary machine utilizing flat or round collectors, which limits the spinning radius to smaller sizes and limits form to flat surfaces. In this project, we're proposing a novel way of fabricating that allows for 3D electrospinning at all scales by reimagining the standard electrospinning device to a dynamic moving system integrating a robotic arm. The following video is a tutorial on how to create this DIY robotic arm electrospinning system for yourself. Let's get started. To start, the system is composed of several different parts and components. The first being the UR20 robotic arm with an attached custom end effector, containing a metallic needle, power supply cord, and polymer tube. The polymer tube carries electrospinning solution to the end effector from the syringe pump, and the syringe pump is designed custom for the system, the digital operating interface, and 4 physical parts. 1, the stepper motor, 2, the threaded screw, 3, a moving frame, and 4, a polymer solution syringe. To power the system, a high voltage power cord is attached to the power supply and the electrospinning end effector. The scaffolding is 3D printed with conductive PLA. And finally, the ground wire is attached to the 3D printed scaffolding. In this video, we will assemble the DIY robotic arm electrospinner in 5 parts. First, we'll learn how to create polymer solutions. Then we'll learn how to assemble the custom electrospinning end effector. Next, we'll learn how to load and assemble the custom syringe pump system and its accompanying web application. Then we'll 3D print our conductive scaffolding. And finally, electrospin using the complete system. Let's start by making a polymer solution. Within our research, we've explored electrospinning with these 4 main types of polymer solutions. But for today's video, we'll be making PVA solution. The standard formula for mixing the solution is written above, and to make 50 milliliters, you'll need 3.5 grams of PVA powder and 46.5 milliliters of distilled water. Beakers, stir plate, scale, a weigh boat, and finally PVA powder. Let's first start by measuring out 46.5 milliliters of distilled water using a graduated beaker. Pour the distilled water into the mixing beaker and put it away. Turn on the stir plate and set to a low heat. Now place the weigh boat on the scale and tier. Now let's weigh out 3.5 grams of PVA powder. Cover the PVA container and put away. Next, slowly mix the PVA powder into the beaker in parts. Use a stir rod to break up large PVA chunks for the stir plate, and adjust heating and stirring levels as needed while keeping the mixture below boiling point. Allow the solution to mix on the stir plate for at least 30 minutes, or until the mixture becomes completely incorporated with no visible PVA chunks. Then turn the heat off and allow the mixture to stand still and settle. Next, let's load out. For this step, you'll need a roll of tape and a syringe in addition to the solution. First, remove the plunger from the syringe. Tape the opening of the syringe Now, slowly pour the PVA solution into the large opening of the syringe. Be careful not to create air pockets in the solution. Fill the syringe to the 10 milliliter mark and take a look at the color. If the solution is very cloudy, then the solution has too many air bubbles and disrupt electrospinning. To get rid of air bubbles, tap the syringe against a hard, flat surface. Check the color of the syringe often. The more clear it gets, the better. Finally, let the syringe settle and let it rest upright for around 30 minutes. After resting, the solution should be more clear. We are ready to attach the plunger. First, remove the tape from the bottom and cover with a paper towel or glove. Next, partially insert the plunger back in and flip the syringe so that the solution sinks to the bottom. And slowly push the plunger in to dispel the rest of the air gaps and bubbles. Try not to push too fast and make a mess. For now, let's set the syringe aside and assemble the end effector. To assemble the custom electrospinning end effector, you should grab the 3D printed parts, a long 6-inch syringe needle tip to be used as a nozzle, 3 small screws, a hex key, a long polymer tube with a syringe attachment joint on one end, And lastly, an extremely insulated high-voltage power wire/tube. First, grab your end effector base and the syringe needle. Insert the syringe through the bottom hole and push to the top. The bottom should press fit into the center holding cylinder. Then, gently lift the needle tip and wedge the raw wire end of the power cord under the metal, and readjust it so that the tubing is snug in its channel. Next, grab the polymer solution tube and attach it through the left side of the end effector. Push the tube through the center channel and secure it to the bottom of the needle. Attach the electrospinning end effector cap with 3 small screws. To attach the end effector to the robotic arm, use 4 compatible screws and a hex key. Done for now! To start, remove 3 out of the 4 screws from the syringe pump's cover and turn it away from the center. Place the PVA syringe within the gap, aligning the flanges to the edge of the pump. Turn the syringe pump cover back to cover the syringe and screw the other sides back in. Next, we need to make sure that the moving frame makes contact with the end of the syringe. First, turn on the ESP32 and connect to its Wi-Fi settings on a personal device of your choice. Then navigate to a browser and connect to the syringe pump's operating application. Set the direction to counterclockwise and set the flow rate to a high value for now, and hit start. Keep an eye on the distance between the moving frame and the syringe and pause the system once close. And attach the end of the polymer solution tube to the open end of the syringe. Lower the flow rate and resume start. Once the polymer solution visibly comes out of the end effector end, pause the app. We are done. After designing your scaffolding on a software of your choice, send the STL to your printer slicer, and set up supports and brims for the success of your print, and send to print. Select your conductive PLA spool. For this video, we will be making a 3D printed wearable mask as a scaffolding with the Bamboo PS1 printer. Wait for your print. Remove supports and clean up the scaffolding. Set your scaffolding on a platform and attach ground wires to either side. Let's start electrospinning. Turn on the power supply and adjust to the desired voltage. Soon after, start the syringe pump for the duration of your spin. The PVA should start electrospinning soon after, with a noticeable cone of fibers coming from the syringe tip. Now initialize your robotic toolpath and watch the fibers form. With the moving electrospinning end effector, you're able to evenly electrospin larger areas and spin specific areas within the scaffolding for specific sets of time.